So, as we have been talking, that oxygen is a very important biosignature of life, and it's the photosynthesis which produces a lot of oxygen. So, if we can get oxygen or abundance of oxygen in an environment, it may mean that there is high photosynthetic activities taking place over there, which is producing that oxygen. But keep in mind, and this is again I have talked when I was talking about the methane, that oxygen is not produced only by biological ways. I mean, there are abiotic processes also which can produce oxygen. So it will not give a definitive proof that life is there, but still the presence or abundance of oxygen in one planet or the other, it will at least increase the possibility. And you can combine it with other data. Maybe you can see along with the oxygen, some other biosignatures may also be there. So one or two other biosignatures also with the abundance of oxygen will strengthen your prediction that maybe life is really there. So in last, I must say, 15 to 20 years, there have been some real discoveries because of some utilization of some very, very modern techniques to search exoplanets, to search different planets. And we now can say with more strength that perhaps our possibility of finding life in other planets has increased now. And one of the reasons is the advent of the Kepler Research Telescope, Kepler Space Telescope rather. It was a very revolutionary step. In 2009 it was made, and it gave rise to the finding of many exoplanets. And then just recently, 2021, the James Webb Telescope was it was sent to the space, and it is giving some very, very groundbreaking results. And I will talk a little bit about both of these innovations of the modern technologies. First of all, let's talk about the Kepler Space Telescope. It was sent by the NASA in 2009. It was designed to find the Earth-sized exoplanets. Exoplanets, of course, as I've told you, are the planets which are not part of our solar system, which are beyond our solar system. They use the transit method. That is, when the exoplanet is moving in front of a star, the light of the star dims, which indicates that perhaps whatever is passing in front of the star is an exoplanet. Of course, from the pattern of the light, from the intensity of the dimming of the light, and so on and so forth, you can predict the size of the exoplanet and its different other features. And the Kepler really revolutionized our understanding of the planetary system. We found not hundreds, but thousands of exoplanets because of Kepler space mission. It indicates that the results of the Kepler missions indicate that our universe is, full of, it has abundant number of exoplanets, because there is abundant number of stars, and of course each star should have its own planet. So the number of exoplanets is abundant in this space, and they are distribution all along our galaxies and other galaxies also. So in this way we can see that because there are many exoplanets, then the possibility of the frequency of the chance that there will be more exoplanets in which life can thrive, that also increases. Then just lately in 2021, James Webb Telescope was launched. It's absolutely the most advanced telescope history have ever been used in history. it's one of the very key feature of this that it can make use of the infrared light. And infrared light is better, is more effective for as far as the seeing in the space is concerned, as far as seeing the exoplanets or other bodies in the universe are concerned, because for instance, the infrared light can pass through the dust and the clouds through which the simple light cannot pass through, and in this way we can see the things more clearly. And also one other important aspect of infrared light is that the bodies which are spaced at a more distant space, or in terms of time also, they release infrared light, and that infrared light can be utilized by the James Webb Telescope to see those distant objects. So in this way, in terms of resolution, in terms of quality, the James Webb Telescope is much more stronger than even, or much more better than even the Kepler telescope. And it is showing its result. Right now, you can go to an actually NASA website, which have its web page for the results of the James Webb Telescope, and you can see how incredible results it's giving as far as the exoplanets are concerned, or as far as other aspects of the seeing the universe are concerned. The molecules which it has detected in many exoplanets, it has detected water, a very, very important component as far as the life is concerned. Methane, we have talked about it. Carbon dioxide, it's very important. And in this way, the analysis of these molecules and then further going deeper into these analyses will bring us more closer to finding the life in these areas. Finally, the use of modern techniques, and I will say state-of-the-art telescopes, specifically the James Webb Telescope, and in future we may make even better telescopes. It shows that how promising is our future for finding the planets which might have life. It also shows the importance and relevance of biochemistry in finding the life over there, because these are the biochemical pathways, which is actually biochemistry. These are the biochemical pathways which are producing the biosignatures. So biochemistry is very relevant over there also. And finally, before stopping over here, let me tell you that just last year, the NASA sent a very, very significant satellite towards Europa, moon of planet, and they think that because there are water bodies over there, because some water was oozing out in the form of fountains from those that moon, so maybe we find some life over there. Actually, that satellite will reach to Europa in 2030. Maybe we in our lifetime witness one of the most, I must say, most important finding in the history of humanity, the life over there.